So in today's episode, I'm going to be talking about different shapes and the development of these shapes. Now, the first we'll be talking about here is the tetrahedron. Now, this tetrahedron is a regular solid bounded by four equilateral triangular faces. So in this case, you can say that this is one triangular face here. And then to the right, there's a second triangular face. I will number them 1. This is second triangular face 2. And then just behind it, there's at the bottom at the back, there's a third triangular face. You can see that's 3. So these dotted lines indicate that that is an edge that is hidden from our sight. So and then bottom, this under with the base, it's resting on a triangular base. So that base is also bordered by this dotted line, and that is the fourth one. So that is why there are 4. 1, 2, 3, 4. So this is a tetrahedron. So it's bounded by 4 equilateral triangular faces. It's a very special shape. Now also we have the development of tetrahedron. So a tetrahedron is developed when you open the shape. You will see that it's actually consisting of 4 triangles rather. So basically this will be the base. This is the base. This 4 we talked about earlier. Then it is surrounded by the slanting side. So from the bottom to the top, is the height. So we'll also talk about this in subsequent videos on development. But today we are just talking about the introduction to shapes and development. So now we also have the tetrahedron in a cube. So you can see that when you have it in a cube, you have the vertices of the tetrahedron coinciding with the vertices of the cube. So that shows that in the volume of this tetrahedron is actually less than the volume of the cube because it can enter into a cube. So this is basically it. Then we also have the octahedron. So it is basically a regular solid bounded by 8 equilateral triangular faces. So in this case, this is one face, this is a second face, this is a third face bounded by 2 hidden edges. Then we have the fourth face. Then we have the fifth face. This is above fifth face. We have the sixth face. Then behind it, seventh face. Then at the left behind, we have the eighth face. So this is an octahedron with 8 faces. And then if we were to develop this is how it will look. So it looks just as if you have 2 tetrahedrons placed side by side with one edge on beside another. So this is kind of like just when you have 2 tetrahedrons, when you place one behind it, you flip it over and then place the edges on each other. So this is how it looks. So if you have it in a cube, this is how it will look. An octahedron is actually looking very smaller. So the more the size, the more the less the number of vertices that can fit in a cube. So because of this tetrahedron can actually fit 4 vertices in a cube. So these are basically shapes and the development. Now that's not all. We also have other shapes. We have the dodecahedron. So this is, by its name, you can judge that it has 12 faces because dodecahedron is dodeca means 12. So it is a regular solid bound by 12 faces, and each of these faces is a regular pentagon. So you can see this is a pentagon, and the pentagon is a shape that has 5 sides. So this is a regular pentagon. So when you combine 12 or rather when you have 12 faces, you will get a dodecahedron. So this dodecahedron is judged based on the number of faces it has. So each face is a regular pentagon. So this face is pentagon, pentagon, pentagon. So we can see 1, 2, 3, 4, 5, 6. There are still 6 faces behind these visible ones. So those ones, they are actually beyond view. But when you develop it, you will be able to see it in real in its real form. And just in case you don't know, this development, when you curve it, you get your dodecahedron back. So if I eventually cut this shape out of this book, and then we fold them according to these edges. So we fold them along the edges, and then we join them together. So we will get this shape, which is a dodecahedron. So we also have the icosahedron. So this is a regular solid bound by 20 equilateral triangular faces. So 20 equilateral triangular faces. So icosahedron, icosa means 20, so it stands for 20. So in this case we have actually pentagonal faces, but in this case we have equilateral triangular faces, just similar to the octahedron and that the other one we talked about. So basically, if you develop it, this is how it looks. If you cut this shape out of paper and then fold along these lines, you will get your shape back. So basically, we'll be dealing with the practical aspects of development of shapes in subsequent episodes of this course. So make sure you watch this course from the beginning to the end. It's a full course, full-blown course that will carry you through the whole fundamentals of technical drawing. Thanks for watching.